Well, ladies and gentlemen, today we are going to use Coulomb's law to figure out a net force on a charge if those charges are in a conveniently located triangle. Today you're going to need your brains and your calculator. Make sure your calculator is in degree mode and not in radian mode, and follow along. We have three charges. We have charge 1 with a positive 19.5 microcoulombs. We have charge 2 at positive 25 microcoulombs. We have charge 3 at negative 11.5 microcoulombs. This X location right here is the origin. Charge 1 is 20.71 centimeters away from the origin. Charge 2 is 33.79 centimeters from the origin. And charge 3 is 25.5 centimeters from the origin. Now, before we even attempt to use our physics knowledge, we must cover some basic information about this formation in order to make our lives easier. First off, let's see exactly how far charge 1 is from charge 2. In order to do that, I'm going to add the two distances together to get 54.50 centimeters. Double check that. I'm good. Next, we need to know how far charge 3 is from charge 2, and I'm going to do that by using our favorite Greek person's equation. That's right, Mr. Pythagoras himself. We got two legs of a triangle, so we need to use a squared plus b squared is equal to c squared. And then you square root that in order to get the distance from charge 3 to charge 2 is 42.33 centimeters. Okie dokie. That's nice and dandy. But what we also want to know is, I know that charge 3 and charge 2 are going to create a force that's going to be in the x and the y axes. And so in order to solve for anything in the x and the y axes, angles are important. From this length to this length, we have a right angle. We have all three sides of a triangle, so if we use our trig functions, we can figure out what the angles are. Choose your favorite trig function and find the angle that is between there in the hypotenuse and there in the hypotenuse. Let's see. I'm doing the opposite side over the adjacent side, the inverse tangent of that, and I get this answer of 37.04. That angle is 37.04 degrees. This is 90, so that must mean that this is 52.96 degrees. I think we're ready. So what the problem is looking for is the net force that these two charges have on charge 2. So let's go solve it. Let's use Coulomb's law. The force that charge 1 has on charge 2 is equal to Coulomb's constant, aka K, times charge 1 on charge 2, divided by the separation distance between those two. K is 9 times 10 to the 9. Q1 is given to us as 19.5 times 10 to the negative 6, which means micro coulombs. And charge 2 is 25 times 10 to the negative 6 micro coulombs. And the distance from charge 1 to charge 2 is 54.5 centimeters. So write that as 0.545 meters squared. We always want to be in meters. All right, and next we're going to plug that into our handy-dandy calculator. And math. Wow! I got an answer, and I hope you did as well. The force that 1 has on 2 is positive 14.77 newtons. Now what that positive means is that force 1, or charge 1, is pushing charge 2 because they are like charges, and like charges repel. So charge 1 will push charge 2 horizontally. This way. I'm gonna write that in. Like so. Wonderful! Next up, we have to see what charge 3 is doing to charge 2. We're going to use Coulomb's law one more time. So the force of charge 3 on charge 2 is equal to the constant K times charge 3 on charge 2, all divided by the distance separating the two squared. All right. K is 9 times 10 to the 9. Q3 is negative 11.5 times 10 to the negative 6 coulombs. Charge 2 is 25 times 10 to the negative 6 coulombs. and they are both separated by a distance of 0.4233 meters squared. And we're going to put that into our calculators, and I hope you are doing so as well, to get wow, I got an answer. I hope you did as well. I got negative 14.44 newtons. Now what that negative means is that the two charges are attracting each other. So charge 3 is pulling charge 2 towards it because they are not like charges. They are unlike charges, and unlike charges attract. I'm going to draw F of 3 on 2 in purple. Write that in. Cool. 14.44 newtons. Now, you might be thinking to yourself, all we have to do now is add them together, right, Mr. Lee? You would be wrong, because this purple force has both x and y components, and so I will separate this hypotenuse component, xy force, into its x and y components. And we're going to do that using some trigonometry. Once again, you're going to need your math device. Luckily for us, we already know what this angle is between this hypotenuse and the x-axis. Now, I'm going to look for the y force first, the y component, and that is opposite of this angle. So I'm going to use the sine function. And I hope you did as well, because I got an answer of 8.70 newtons upwards. Because components aren't real forces, I'm going to write them in as dotted lines. Wunderbar. Next up, we need the x component of that purple force. So I know that this is the angle, and this is the side, and it's adjacent to that angle. So I will use my cosine function to find that this x component is 11.53 newtons. Wow, so pretty, so colorful. Okie dokie, we're almost finished. What we have to do now is add both our x and y components separately. My net x forces comprise of negative 11.53 newtons, negative because it's pointing to the left, and positive 14.77 newtons because it's pointing to the right. And we get a total of 0.53 minus pressure, 3.24 newtons. Cool. Now let's figure out our net y force. Our net y force is just 8.7 newtons. Cool. So we have our net x and our net y, which means we have two sides of a net force triangle. Our net force will be 3.24 newtons to the right and 8.7 newtons in the y positive. We have two sides of a right triangle. Do you know what to do? That's right. If you're thinking to yourself, two sides of a right triangle, I must use the Pythagorean Theorem. You'll be correct. And I hope you are, because I found that answer. The net force is 9.284 newtons. That is the total force that charge 2 will feel from charges 1 and 3. However, we're not finished. We have to figure out the direction. So in order to do that, we have three sides of a right triangle. We can use our trig functions to figure out that angle. Choose your favorite one. I'm going to use the inverse tangent one because I have my opposite side over my adjacent side. And I get to the angle of 69.57 degrees. So my final answer is that the net force on charge 2 is 9.284 newtons at 69.57 degrees. And that's because it's in quadrant 1. If it's in quadrant 2, you got to, do 180 minus whatever angle, and so on and so forth. All right, fingers are crossed. Let's see if I got this correct. I'm gonna plug in my answers. I don't know. Let's see. All right. It's time to plug in my answers. My net force on charge 2 is 9.28. My direction is 69.57 degrees. Fingers crossed, fingers crossed, fingers crossed. Take a snapshot of this. Let's do it! Yeah! I did it! I'm so good. I'm number 1. Thank you very much.